Alright, after playing with this whole deal for a while, I feel like I'm finally getting a better understanding of how all the physics come into play when configuring this type of deal. As you can see, it's going right now. It is a fair distance from the coil, and I'm running it at 5 volts right now, which was the goal. Now I can adjust the voltage and obviously change around the variables and still get it to run, but the goal was 5 volts. Now the stability that you actually see it at now, if you can call that stable, is about the best I've been able to get it. And this is due to a lot of different factors, but without that little tiny magnet fragment that I have on the bottom of this screw down here, it actually just loses all stability. So that little tiny addition of extra weight there made all the difference. If I was to remove that, this thing's going to start going weeble wobble and eventually oscillate to the point where it either jumps up and sticks to the coil or it falls down. Getting this stability has been some of the probably the most difficult part for me, because you have a combination of variables where, especially with my setup, since I have the a metal core in this coil, so there's a point where it actually will, upon its own magnetic force, jump up and stick to the core. So I have to keep it out of that range, but at the same time, depending on the amount of weight that's there and the magnetic pull that the coil is capable of at a certain voltage, obviously, I can't let the set point become too far. So right about there has been a good point for me, but even so, without changing variables around, I've noticed that just the slightest little change in orientation of that Hall effect, which is right, it's really hard to see, it's right down there. You can sort of see the outline of it right underneath some tape, so it's not solidly fastened there to any degree, but it's in a decent enough spot. In which, by the way, this is the most basic setup I can get right now, and I'm essentially just changing the set point as I go. So it's basically a game of more or less finding a general region with a set point that I determine using the serial monitor on the Arduino, and just getting a gauge of about right where it needs to be as far as oops too close to the core or oops too far away. From there I can sort of get a general idea and just hone it up or down based upon what I can feel with my fingers and holding it close to the sensor while the circuit's running. So in this case, what I've got a set point of a value of 365 in my code, and I'm more or less just getting a feel for, I guess, the gradient of change, and I'm changing it, 364, 363, 362. I'm sort of just changing it till I get to a perfect point, a perfect set point in my mind, and so far that's really just been wherever it was the most stable. Now likewise, the voltage obviously matters here too. If I was to change the voltage around, that throws everything around. I've got more or less a range up or down that it's not really going to affect the circuit, but obviously if I crank that down a little more, it probably won't have the force to hold up the magnet. If I crank it up too much, I might be in danger of having too much force pulling it up, and it'll just overpower and stick to the core. So if I wanted to run this from 12 volts, let's say, obviously I can get by with a heavier magnet and weight. These are just some ones I had laying around. I've tried some other ones. I had another spherical one that would have worked great, but it was just a little bit too heavy, and I didn't want to drive the coil at the 20 volts it actually needed to hold that. But I also think 5 volts is a pretty good deal. That's what I was shooting for. The coils, if I even have any of these coils. Oh yeah. using these coils right here. Now they've got a core in there, obviously, with a screw hole. And I found that I could probably get away with just one of them. But I felt by using two, I would get a little bit more distance on my pulling power. And I'm not entirely sure if that's true, but anyway, I just put two of them in series. That's the result. I noticed that obviously there's different ways to go about doing this. You've got some where people are basically forming a ring of magnets to repel an inner magnet in just the right location. And obviously you're going to need some other form of stability to keep that magnet from moving around and getting out of place. So that's why they add some center coils. Those center coils use a sensor to, determine the magnet's location, and they make sure that they lock it down in place, I'd imagine, by pulling them in. And you can create a balance there. I've also seen another really cool one out there where somebody took two opposing coils and they put the magnet in the middle and just suspended it midair with the two coils fighting over it. And that was also a pretty cool idea. And as far as the suspending it from below, that I think that's cooler because obviously you can have something hovering and you can place a weight on it. So that's another thing I'm going to work on. I haven't decided how to go about that. I noticed one guy out there was using one center coil with a ring of magnets around it, and he got that to work, which is pretty cool. But most circuits out there seem to use an arrangement of 4 of these in the center. So as far as the best way to go about that, I'm not really sure. I would want to make mine as low power as possible, though. In this case, like I say, it's kind of it helps to have a scope. Let me put it that way. It helps to be able to have a scope where you can actually look on your scope and while you're moving it up and down to see exactly where that coil is cutting on or off. Which in this case is basically the simplest way to do it that I've seen, is where you're basically just telling the sensor, or you're telling your transistor, in this case, when to cut off. And you're telling it when to cut off according, to how close the magnet is, and the sensor sees that. And it's just using gravity. You're just fighting gravity using the magnetic field from the coil at the right specific time, and you just set a spot. And it's just as basic as it gets. Now, obviously, if you use an air coil, then you're going to have the benefit of not having the magnet get too close to stick to the core. I just didn't actually have a way to wind a good enough air coil right now. The sensors I ended up using are AH3503. They're about pretty much common with what other people use, about 4 to 6 volts or so. Seemed about the sensitivity that you need, a linear sensor. As you can see, I'm just using the 213055. So that's it. I've just got this Hall effect sensor down here with this 3 leads coming down, just plugged into the analog and the power rails, and that's it. Really simple, and you saw how easy the code was. You do this so many different ways. And what I have noticed, though, is a lot of people are using Darlington power transistors, tip 120s, which I do have some of. I'm going to try that also. But I would imagine, I guess, if you use a tip 120, you're going to increase the power consumption of the whole deal, but you're also going to be able to fire more juice out of this coil. Because I'm actually surprised that coil is firing like it does anyway, because through that 1K, what this 213055 is seeing, I'm surprised it's switching hard enough at all, but it does in this case. And if I was to use the tip 120, I could probably get a lot more juice coming out that coil, which means I could use a much heavier weighted suspended magnet and maybe get a little more coolness out of this effect. Alright, so I'm going to show it what it does with just this, without the little bottom fragment. Still at around 5 volts. And just put it in its spot. So you can see basically the coil is on. It's on right now. I can feel it. It's just not strong enough to pull this magnet up till it reaches a certain point. I feel it. It's pulling the screw with it and the magnet, but there reaches a point where you could just feel that set point. You know, it's sitting there right now, but you can see as the oscillation gets out of control, boom, it wanted to jump up and stick. It doesn't matter how gently I place that there. It's just going to happen on its own. It's going to oscillate. It's going to pick up an oscillation, and eventually it's going to rock itself into catastrophe. Now, in this situation, it just so happens that by adding that one little piece, it gives it the weight it needs to be stable. So if that gives you an idea of how delicate the balance is there. You see it still wants to sort of oscillate. It's just got that extra weight to keep those tiny little vibrations from getting out of control. I've also put some little magnets on there. I've noticed it was pretty cool because of the oscillations. There's a couple times it got itself to rotate, and it would spin around at incredible speeds before actually sticking up. So I was like, man, I wonder if I could, figure out how to take advantage of that some type of way. But if you're playing with these, oh man, it's so many factors. But like I say, it's more or less a game of eyeballing, guesstimating a set point value, changing it, and moving it closer and closer to where you think it should be until you reach a point where you say, okay, can it get any better than this? No, let's leave it at that point. And if any of your other variables change around, then it's probably not going to work anymore. So we could take the voltage here, and we could see if I can make sure it's as stable as possible. We can see at what point, at what voltage, it's just not going to hold that sucker up no more. As it oscillates more and more, it's going to lose itself. So we could just barely get away with that from a fresh lithium. Just barely. Yep, and there you go. So about 5 volts standard USB output is pretty much what you need. Or so. But that's not necessarily true, because what I'm doing right here is I'm pushing up on the magnet, and I'm seeing how much higher I could go from the point it's naturally floating. I'm seeing how much higher it could go before it wants to pull up and attract to the magnet. And I've got just the tiniest little bit of leeway here where it will fall back on its own weight. So I could technically adjust that set point a few hairs closer to where it'll want to naturally sit a little closer. At that point, I might be able to get away with driving it with less voltage, if that makes sense. But right now, this is the particular delicate balance that it needed according to that voltage. And the weight and the coil and what the sensor was seeing while interacting with the coil, because there's only one sensor. So many variables. Essentially, this is just something that takes time and tinkering either way. You don't need to use an Arduino, but I've actually found for this particular project, it's super freaking handy. And you know, they say you want to use linear Hall effect sensors. I'm not 100% sure why that is. I would imagine maybe it's because the linears are maybe much more accurate and more sensitive. But in this arrangement, you're basically using this linear sensor only for the reason of being able to determine a precise point, which you then set to essentially give a digital on-off. So basically it's a digital switch that you're doing ultimately, but you're just using this linear sensor to have a more precise switch point. I mean, I would imagine that's what it is. If you tried to use a switching Hall, I don't know, maybe the sensitivity won't be to the point where you can get stability. But at any rate, that's basically what you're doing. You know, you analog input, your output pin from the sensor is just feeding into the Arduino, and that Arduino from there is using the voltage to give basically a number, and then you take that number that it's translating, and you know, you basically just say, okay, well, at which point do I want this to happen? And that's your set point. At which point, when it does hit the set point, you know, Arduino is telling something to cut on or off. So it's just telling this pin high or low. At which point, when it does turn on, it's just sending that 5-volt output signal into this the base of this transistor, you know, through this 1K resistor, which is keeping the voltage down and the current to protect that pin as well. But it's basically just switching this transistor on a little bit, on or off, you know. So it's just an on or off deal, you know. And this is why people are able to do this using other switching methods, such as, you know, optics or things like that. I mean, you're just setting a point for it to switch on and off. And I guess it can get a lot more complex than that, but that's pretty much all it is. So, you know, you can see in this setup, as far as it's wired, I've just got a coil up here. The black and white, or black and red leads are the coil, and one of those is basically going to power in, and the other is going to the transistor. Common switching arrangement. I just have a blocking diode here in between the coil, as per normal. So that's all that is. Using the Arduino to not only power the sensor, but to switch the transistor, and that's all there is to it. So while I think this is pretty cool, essentially the suspension method, fighting gravity, with just simple switching on and off, I could technically take that Arduino or get another little tiny module, just slap this all in here, keep using a 2N3055. I really don't even need a heatsink for it. Maybe throw a small one on there anyway. And I could run this little deal from USB power. At maximum, from 5 volts, it's pulling about 300 milliamps. Now that's give or take a little hard for me to tell, or at least the way I measured it before using the clamp, but that's about the ballpark I was getting. What I would probably prefer to do is, I think it's cool to have one of these. I'll probably leave that how it is, or figure out some other little cool thing to do with it. But what I'll probably end up doing is try to make one that repels it from the base and also keeps it locked in place. Now, whether you want to call that levitation or suspension, I don't know, but I think that's pretty cool, just because it seems to me, I don't know, you can have more fun tinkering with it, and add things on it, and maybe even use that as a base for, you know, rotating something. But that's about the next thing I'm probably going to try to work on, and I'll be snatching the Arduino from this to do that. But like I said, I did just think it was cool, you know, for 5 volts you can get a little deal like this going. It's not going to suspend something super heavy, but see, it's actually pretty stable now with how I've got that. The thing about YouTube is usually someone else out there has already done most of the work. And really helps to be able to look at other videos to at least generally get an idea of what's going on. And I did run across a basic schematic that was using the 2130555, so that's when I was like, all right, that's as easy as it can get, and it worked for me because I wanted to use low power, so I really don't need to get any more complicated than that. But you got guys out there like this gentleman here. He basically took the same setup and just expanded on it a little bit. So he's got a core in his coil, and he's basically using the same deal, but he's expanded on it a little bit. He's using a tip 120, but he's also put little momentary so he can adjust the set point. Same deal though. Like, here's an example of a guy who, you can see he's got one center coil and then these outer magnets, and he's levitating actually a cube, which I wouldn't have thought that would actually work, but that's pretty damn cool. And you know, like this guy is showing off a store-bought model. You can see they normally use the 4. They've got this huge ring magnet on the outside to serve as a repellent for the inner magnet. And here's another example. This guy's also got a single core, and he's floating something that's held in place, which is also pretty cool. But I'm wondering if maybe this is the way to go if you really want to support anything with significant weight. So that's why I'm kind of going to look into that. But as far as the basic setup like this is probably the easiest way to go. And that is a pretty good little schematic right there. Now, you don't actually have to add the switches and use code as complex as this. You can use the simple code that I did, but this is actually a little more handy. Probably get the tuning done a little quicker on the fly. You don't actually have to keep plugging in your Arduino and uploading a new number for your set point. So this right here is that guy's channel who made that schematic I was showing, going by Juan Segardo, I believe is his name, on YouTube. So he's one guy that had a pretty informative video. And here was another one, the signal path. He's got a pretty good video. He goes into a lot of detail, just about the different ways you can go about building these. And then likewise, this is the first actual schematic I came across where he was using the 2130555. What is this? Hobby projects on YouTube. And so this is basically the setup I'm using. Pretty much the same thing that this guy's using. But that's essentially what you're looking at as far as hooking up the Arduino. It's just that simple. And as far as the code, this gentleman here has a link in his video on hobby projects. So where if you look up the code,